Imagine you're standing at one end of a large room and your friend is at the other end. You whisper something, barely audible to the person standing next to you. But your friend can clearly hear what you said. How amazing this would be, right? Is this possible? What do you think? Well, this magical thing is possible if the ceiling of the room is spherically shaped like an ellipse. This shape, which looks like a stretched circle, is what makes the whispering magic possible. If the ceiling of the room is elliptical in shape, technically semi-elliptical here, then there are two special points in the room where you and your friend can stand. If one of you whispers something, then all the sound waves get reflected from the elliptical ceiling towards the other person. So as the sound waves from one point get reflected and focused onto the other point, your friend can hear your whisper. This works the other way around as well. If your friend whispers something, you will be able to hear clearly as well. Based on this reflective property of ellipse, many rooms called whispering galleries have been constructed. For example, there's one at the Grand Central Terminal in New York City. Isn't this shape interesting? Each of these two special points of the ellipse is referred to as focus. And together, they're called the foci of the ellipse. Wait, there's more. How do we understand the shape of an ellipse? Suppose we have 2 points in a plane. We name this point as F1 and this point as F2. Now consider a special set of points on the same plane. They are placed such that their sum of the distances from these 2 points is constant. Let me explain. Suppose we take a point here. Let's name it A. Now let's say the sum of its distances from point F1 and point F2 is some number alpha. Now consider all such points whose sum of the distance from these 2 points is exactly equal to alpha. Are there any such points? Yes, there are many more. Collection of all such points is called an ellipse. Let's say we take a point B on the ellipse. Then the sum of its distances from the points F1 and F2 will be alpha. Let's take another point C here. Again, the sum of its distance from these 2 points will be alpha. So we see that the ellipse is a collection of all points in a plane such that their sum of distances from the 2 fixed points in the plane is constant. Now suppose we want the constant sum of distances to be beta. Let's say beta is greater than alpha, then the set of points corresponding to this constant beta will be this ellipse. If we take the constant to be the number gamma, which is less than alpha, then the ellipse will look like this. Now let's look at one ellipse. An interesting thing happens when the 2 foci of the ellipse coincide. Can you guess? We get a circle. All the points will be at a distance of alpha over 2 from the center, where the 2 foci coincide. So we see that a circle is a special case of an ellipse when the 2 foci of ellipse coincide. So now we know that for an ellipse, we need to know 2 things. First is the 2 fixed points called the foci of the ellipse, and second, the constant sum of the distances of the points on the ellipse from these foci. Then the ellipse is the collection of all the points whose sum of the distances from the foci is that constant. Now many of you may have a question from our example of the whispering gallery. Suppose you and your friends are in a whispering gallery with an elliptical shaped ceiling. How will you know where to stand to hear the whispers of each other? That is where the foci of the elliptical ceiling are. For this, we need to delve a little deeper into understanding this shape. We will look at this in the next lesson. There we will understand some terminologies associated with the ellipse.